focus for our feeder system is energy, and how we're supporting that at the elementary level is providing background knowledge with wind and weather. We have studied pinwheels, anemometers, and have started to introduce the concept of wind as a renewable energy source. The students are really excited about weather. They have self-selected a natural disaster, and so we're flex grouping between the 4 classes in our grade level. And we've turned that into a disaster design challenge. So we're in the empathy stage right now, learning as much as we can about the self-selected disaster. I'm teaching about wildfires. And the next stage will be defining the problem and how to communicate that to the people. So our students will prototype a newscast and we'll present that to the class on a green screen, showing all what they know about their particular disaster.
So my group is tsunami. I really wanted to know what tsunami is, but now I know. We made pinwheels to use the resource of energy and how it rolls on and never goes to a different place and never comes back. We are Mead Energy!
Students are currently designing wind turbine blades to figure out the optimal output with different designs. So by the end of the week, we're hoping to have the best design possible with number of blades, material type, best angle of the turbine blades. So just a variety of different variables to test. Lots of fun, lots of hands-on stuff, lots of design projects, so we get to do a lot of different things, which is a lot of fun.
Today in Intro to Energy class, we are, as you can see if you pan the camera, we are building windmills and the angle of the blades to see what windmill will catch the most energy. We're sort of trying to see which ones is better, less blades or more blades, what weight is added, what weight is taken away. Mostly, a really fun part of going to test your windmill out is seeing what'll work, what won't, and that little reflection blast of air you get whenever you go to the fan.
This is Energy Industry Practices, one of the Energy Academy required classes. It's the second year class. We really look at more what's happening in the real world. So we have guest speakers come in, we take field trips, and they work on projects. And so they each are doing their own individual project, or maybe a couple kids are paired together.
We're learning a lot about as the name would imply, how the energy industry works. So we started out the year talking about how it would look in just a normal business. We wrote resumes. Right now we're working on these projects, which are just various kind of interest projects in the energy field. And then we have kind of ongoing, coinciding with these projects, we have units that are just about the energy industry, you know, the workings of like the power plant, basically how like power is generated. I'm doing wind, so I had a wind turbine, which there were blades that were designed by a student last year, and I was testing what angle they would be most efficient at, and we were adding mass to it. So what we did was at the end of the wind turbine, we taped a dime, then we taped a penny, and then a quarter, and we saw which one had the most efficient mass. And I think the results ended up being that if you had it at 30 degrees with the dimes taped on the end, that was the most efficient.
The ideal outcome is to give students an advantage into whatever their post-secondary pursuit is. However, we can help them to stand up above their peers when they go to that next level. Just give them some good authentic experience and help them learn how to think. Make them aware of the world that they live in, that we live in, and how they can be a part of the solutions to a lot of the problems that we have.
The Mead Energy Expo, we're excited about. It's the very first annual one. So as a middle school and an elementary all being in the same Mead feeder, we really wanted to all come together and highlight all of the great things that happen at every level around the area of energy.
I made a water vortex, and that air tube makes air and it circles like a tornado, and if you put your finger in, no air, no tornado.
A circuit is the path that the electricity takes from the power source and goes through a series of wires and ultimately ends at the object that needs electricity to work.
This is a solar oven that I made. It's so how it works is the sun comes down to here, and then the tinfoil reflects into here, and then the sun heats the box up, and then so it cooks the food.
So my middle school students are showing off some of the different experiments that they have done with energy, with wind and solar and energy transfer.
We're trying to get the fruit to conduct energy because it has citric acid in it, which works as an electrolyte solution. So when you put the copper wire and the zinc nail in it, you kind of compare the data of the fruits and see which one actually produces the most energy.
We're trying to see if 6 solar panels will of course will produce more energy, but we're just seeing how much energy it will produce. And then we'll see different shades of color, if that affects it at all.
This is last year's solar car. We just kind of revived it.
Here we have all the solar panels on top of the car, and we have, let's see, about 16 of them on here, and it captures all the sunlight and it takes it all the way back here into this battery, and then it helps this car run. And we're making actually another one later this year, and we're going to try and learn from our mistakes last year and try and make it better.
Basically what I'm doing is separating, or actually extracting, the ethanol from cattle corn and sugar beets. And by doing that, I will basically be using a distillation apparatus, and I will be heating up what is called a mash. It's basically just going to be the ground up cattle corn or sugar beet, and I will be mixing just a little bit of chemicals in there. And what it'll do is it'll separate the water from the chemicals, and the finished product will basically be ethanol and something that could be cleanly burned.